So, Sam's, we just got done doing mole conversion.
Yep.
So what are we going to do today?
Now we're going to use the mole conversions, only we're going to add an additional step. So we're going to go from, let's say, grams into moles, and then moles into something else, like liters.
So today, guys, we want to talk about multi-step problems. It's really the same stuff.
Same thing.
But we're going to just do bigger problems.
One more railroad track.
So, yeah, exactly. Adding an additional railroad track is all we're going to do.
Exactly. We're just going to do a few examples for you to show you how simple it is.
So just copy down the examples. Make sure you're getting the calculator to follow along with our calculator, and then you'll be good. Okay?
Yep.
Okay, so actually, first of all, what we want to do is realize that there's the same three conversion factors that we had earlier. Let me move the calculator out of the way. There's the same three conversion factors. So we're not going to change, guys, which conversion factors we're going to use. We're going to use the same conversion factors. We're just going to use them, well, multiple times.
Right. We're going to use one and then
another, and then another. So let's just do some examples, okay? All right, so let me get the calculator. All right, Mr. Sams, what kind of problem do you want to do?
Oh, let's go from grams to liters.
So let's say that I have
4.6 grams of chlorine gas, Cl2.
Why is chlorine gas Cl2?
Because it's one of the diatomic molecules.
Okay, good.
Yep.
And so I want to convert to what?
We're going to go to put that into liters of a gas at STP.
Liters at STP. All right. So we start with what we know.
Right.
Always start with what you know.
4.6 grams Cl2, put it over 1.
So, you know, I think white might work better here. Okay, hold on. Let me change colors, guys. There we go. 4.6 grams of Cl2 over 1.
Now, we do not have a direct conversion from grams to liters.
So we're going to go from grams to moles.
Yes.
Kind of the gateway is moles.
Always. If you are doing a chemistry problem and you can't figure out what to do,
go to
just convert to moles. And you'll get some credit for just converting to moles.
Go to moles.
Always.
All right, so I'm going to say grams on the bottom because I got grams on the top, and I'm going to go to
moles.
Moles.
So how do we go from grams to moles? We use the molar mass of Cl2.
So Cl2, chlorine weighs 35 and a half, and there's 2 of them, so times 2, 76. So I can 71, isn't it?
71. I can do math in my
2
head.
times 35.5 in case you need a calculator. That would be 71. 68 in Spanish.
Ocho?
So ayuno. Sorry.
Yeah.
Oops. I'm so good at my Spanish.
My preschooler's learning some Spanish.
Yeah,
so
grams. This should say Cl2, shouldn't it?
Yeah.
Mr. Bergman forgot. He got a little naked there.
Naked numbers.
Woo!
Avert your eyes.
Oh, yeah. I'll leave the clothes on.
Yeah.
All right, so the grams is Cl2.
Please.
And now I guess add one more step.
All right, so now we need to go from moles.
So the moles are on top, so the moles will go on the bottom.
And we want to go to liters.
And then liters. And so the
and
one
Cl2.
22.4.
Right, because the
still a little
conversion
naked.
from moles to liters is 22.4 liters in 1 mole. So the moles cancel.
Moles of chlorine gas.
And we have liters.
That's right. So now I just take the computer or calculator or whatever, and I do the answer. So numbers on the top are times, the bottom are divided. So I'll take 4.6 divided by 71 times 22.4, and I get
1.5 liters of CO2.
Liters of chlorine gas.
That's not much chlorine gas, but if it was chlorine gas, you don't want that much around.
Yeah, chlorine gas, yeah.
It's
and
nasty.
Mr. Sams, didn't something happen here with gas yesterday at the school?
I don't know what you're talking about.
I was in Denver, and I got texts. I got all these texts from students saying, what did Mr. Sams do? He evacuated the school.
Yeah, set off the smoke detectors.
Yeah.
Everyone had to get evacuated.
So, well,
Second time in my career it's happened. How many times have you done that, Mr. Bergman?
4.
4. See, you aren't a good chemistry teacher until you've evacuated your school
At least a couple of times. So, Mr. Sams, you're on the road.
I'm well on my way to becoming a good chemistry
teacher.
teacher.
So, yeah, you know what? It kind of works for me.
Yep.
Okay, what else should we talk about?
Let's see. That was grams to liters. Let's go from liters to particles. Let's go liters. Let's start with, 35.1 liters of helium.
Ooh.
And I
Makes you talk funny.
Yes, it does. We're going to convert that to atoms of helium.
Okay, so we want some atoms of helium.
Yeah,
okay.
Let's do that.
What does a doctor do?
Checkups.
Helium.
Boo.
See, helium.
Boo.
Okay. Anyways, you didn't like that? I thought it was great. Okay. So 35.
All right. Write down what you know and put it over 1.
Liters of helium. Over 1.
Okay.
And of course, if I got liters, I'm going to put liters in the bottom.
And we got to go to moles. The first step, always go to moles.
Moles. And I'll say moles of helium. Now, since we're at STP, we didn't say that the problem would say STP, standard temperature pressure. 1 mole is
22.4 liters.
22.4 liters of helium.
So liters helium cancels.
And
now we have moles. Now we need to get moles to atoms. So moles on the bottom, atoms of helium on the top.
To atoms of helium. How's this color working, Mr. Sam's? I'm a little worried.
I liked it.
Okay, 6.02 times 10 to the
Right.
23rd.
There are always 6.02 times 10 to the 23rd particles, of which atoms are particles, in a mole.
Yeah.
So now we do the math.
So that's simple. 35.1, 30. Just clear it.
Yeah.
It's easier to see. 35.1 divided by 22.4 times 6.02. Second function E. 23. Enter. So I get
9.43 times 10 to the 23rd. Atoms.
atoms of helium.
Helium.
All right. That's not too bad.
Nope.
Easy schmeezy.
Yeah. So that was grams. Let's see. We've done grams to liters. We've done liters to particles. Let's go.
Liters to particles.
We just did liters to particles. Let's go particles to grams or grams to particles.
Particles to
Pick
gram.
one. Particles to grams.
All right. So let's say we've got.
Let's do molecules this time.
I have an idea.
Okay.
What if we said you had one molecule?
Ooh.
This is a tricky one. Of zinc chloride. Now,
Let's not use the chloride.
yeah. Actually, you can't do molecules of zinc chloride.
Yeah.
One molecule of dinitrogen pentoxide.
There you go. Perfect.
And I want to know
How many
how much does it weigh?
grams?
What's its mass?
Yeah, I like it.
Now, first of all, I was kind of mean, Mr. Sams.
Why?
And I was mean to you, wasn't I? Because I didn't give you the formula of dinitrogen pentoxide.
No, guess what you're going to see in your test? Because you learned how to name compounds the last unit.
Yeah, because in the last unit, you learned how to name these compounds, so you've expected to know that. So
Yeah.
it's one molecule of dinitrogen
Dinitrogen pentoxide. Okay,
Okay,
di,
well,
nitrogen. Di means two.
in two, yeah.
Yep.
See, this is-
Tent oxide.
Now, why isn't there like a Roman numeral in here?
Because Roman numeral. We put Roman numerals on transition metals.
Well, but that doesn't sound right. What kind of a compound is this?
That's a molecular compound.
That's right.
A
See,
covalent
folks, the key
compound.
things in a covalent or a molecular compound is that you use the Greek system of di and penta and
Yeah.
stuff like that. If I'd asked for like iron 3 chloride, that's ionic. So you got to kind of play that game. Don't forget that. We learned that in the last unit, but it can get kind of confusing. All right. So one molecule of N2O5.
N2O5. Okay, so we're going to convert that into moles, I'm assuming, is going to be our first step.
Always to moles. Yeah,
Always.
You said that. Molecules. By the way, the abbreviation for molecules is MOLEC.
Molec.
Molic. N2O5.
5, not 2.
2O5. That's just 5. You didn't see that? All right, to atoms
Moles.
or moles
Moles.
of N2O5. So that's kind of weird. Molecules and moles at the
Yeah,
same time.
be
Yeah.
careful.
1 mole, and then this will be 6.02 times 10 to the 23rd.
Always.
So the molecules of N2O5 cancel.
Okay, so now we're in moles. We want to go to grams. So that's easy. Moles goes on the bottom.
So moles, and I'll say grams. Now I really
Grams.
should say N2O5, but I'm
Uh-huh.
kind of running out of space because my
We'll write it above.
N2O5. Yeah. Okay. So
Okay.
the grams, this is we're going to have to add it up.
All right.
Nitrogen weighs 14. There's 2 of them,
14.
so 2 times 14. And oxygen, this will be 5 times 16, and we'll just add those together. So
Okay.
let me go over to the calculator guy here. I bet I can move him over just a bit. There we go. So I can say 2 times 14 plus 5 times 16 gives me a molar mass of 108.
108.
So that goes with the gram.
That goes with the
number.
grams, always.
108
Because
grams.
1 always goes with the mole.
Now I just get the calculator out.
All right.
Now I'm going to start with
1.
1. Now, I thought we did the normal 1.
Yeah, but it's our starting number. You
Yeah.
always put in your starting number.
So you divide it by
6.02.
6.02 second E 23 times
108.
108. So if I had 1 mole or 1
One
molecule
molecule
of N2O5, it would have a mass of 1.8 times 10 to the minus 22nd grams.
Wow.
That's a small number.
That
but,
is really small.
But it's just one
Tiny.
molecule of
Yeah,
N2O5.
7 atoms total.
Next, interesting question. Significant figures on this, Mr. Sams. What would you do with that?
Ah, boy. I'd go with 8. 3 significant figures from the 108.
Yeah, because you'd
Yeah.
say, wait a second, there's only one
But we can
significant digit
count
there.
that, so that is a non...
Yeah, this is actually an exact number.
Yeah.
One molecule. You can't have like 1.5 molecules. You
Right.
would have 1 or 2 or 3 or
Right,
whatever.
yeah.
And so because the 108 is actually our least accurate, you would actually say 1 point. So it's actually more accurate to say 1.79.
1.79, yeah.
So that's a little tricky thing on there, isn't it?
Yeah.
Yeah, okay.
Wait. Your number's naked. You just put grams.
Oh, grams of N2O5. Yeah, sorry.
That's good. I think that's probably good.
Yeah, so guys, the key thing is just to kind of manipulate those those
conversion
factors that we see right here. These are the key things that you want to watch, and then you're going to manipulate them so that you can get the answer. You usually always are going to convert to moles first.
Yeah.
In fact, probably always.
Yeah.
Yeah. So
When in doubt, convert to moles.
there you go. Well, we're done. Bye.
Yeah, and bye.